Welcome to the Design Vault, a show about the past, present, and future of design. The Design Vault is a conversation hosted by Shum and Thamer Abanami, reflecting on iconic products and ideas from the past and rethinking them from new perspectives.
Season 2. Hey, Albert, are you ready?
Yeah, I'm ready. What are we talking about today?
Today, we're talking about one broken watch, hundreds of prototypes, and 3 engineers. It's the story of the G-Shock DW5000C, the first G-Shock.
Well, Thamer, what really fascinates me about this story is how a personal moment of failure, breaking a watch, led to this incredible design journey and really the creation of a whole new product category.
100%. I think it's a really good example of how sometimes personal setback can lead to some of our greatest breakthroughs. And this particular breakthrough would go on to influence not just watch design, but also how we think about durability in everything from smartphones to portable speakers to cars.
Well, before we dive into the G-Shock story, we need to understand where Casio came from. Because this wasn't really actually a watch company, was it?
Originally, no, it was not. And that's what makes this story even more fascinating. Casio was founded in 1946, right after World War II, by Tadao Casio.
Well, I assume that's where the name Casio came from the founder's name. And their first product wasn't even electronic, right?
No. Actually, this is the kind of coolest thing we ran into in our research. It's unexpected. The first innovation out of Casio was actually a ring that could hold a cigarette called a Ubiwa pipe. It allowed the wearer of this ring to smoke a cigarette down to the very end, which was crucial in post-war Japan when tobacco was scarce and expensive. It also allowed somebody to freely use both of their hands while holding a cigarette.
I assume that made it really much more efficient, but it also gives a whole new meaning to put a ring on it.
I knew you were going to say something like that. I knew it.
Well, actually, how do you go from cigarette rings to calculators and watches?
I think that moment where the company starts thinking about something new comes in 1949 when they saw an electric calculator at a business show. It's 4 brothers that had started this company together, and they spent years developing their own all-electric calculator. And in 1957, they released the 14A, which is Japan's first all-electric compact calculator. And there are a few setbacks here along the way, and I think, Albert, this is an example of post-war hustle.
Yeah, and I think that time, especially post-war in the 50s, it was obviously a tumultuous time. Initially, a trading company invested in Casio, but then they withdrew their funding. And that's when Casio really had to kind of find a new partner. And they were able to partner with a office equipment wholesaler to sell their first calculator. And that was, I feel like that was one of the key moments of the founding of the company.
100%. And that really allowed them to go to what was next, which was watches.
Yeah, let's set the stage for what was happening in the watch world during the 1980s. There was a lot happening in the 80s.
Yeah, I'm a self-professed watch nerd, and this was a revolution. The early 80s was a revolutionary, late 70s, revolutionary time in the watch industry. The established order of Swiss mechanical watches were being completely upended by what was known as the quartz crisis.
Can you explain more about quartz technology? I assume it's not just about crystals, and there's actually a lot more there.
It is about crystals. There's a lot more there also. I think we'll talk about how quartz works. Quartz technology is basically a tiny quartz crystal shaped like a tuning fork. When the battery sends electricity through it, the crystal vibrates exactly at 32,768 times per second, like a super precise hummingbird wing. And these vibrations are consistent, and they get turned into electrical pulses, which then are used to translate to time and then update that time to the screen. And that's why quartz watches are so reliable. The crystal keeps near perfect time, where mechanical watches would lose 3 to 4 seconds a day. Quartz watches would lose that in a month or longer.
Right.
So it made things cheaper, made things more accurate, and also smaller.
And it sounds like quartz technology fundamentally disrupted the whole market. It created this transition in the watch industry.
100%. It created an environment where radical innovation became possible. Japanese companies like Casio and Seiko were approaching watchmaking from an engineering perspective rather than the traditional craftsman approach. Maybe for a future episode, we can talk about how the Swiss watch industry responded to this crisis, because that's an equally fascinating story.
Yeah. I mean, there's a whole story around Swatch and the collective and how they responded. But back to Casio, let's talk about the G-Shock. I would say the creator of the G-Shock, Kikuo Ibe. He wasn't actually a watch designer by training, was he?
No, and that's one of the most interesting parts of the story. Ibe joined Casio in 1976 as a mechanical engineer, and that outsider perspective would prove crucial to breaking conventional thinking about watch design.
Wow, there's so much to unpack there around the cultural approach to product development. But the inciting incident, I would say the broken watch incident, I think that was a key moment. Back to that spark of innovation.
Yeah, we've been kind of referencing this broken watch throughout the episode so far. In 1981, eBay had a watch from his father. It was a graduation gift, and it fell on the floor and shattered on impact, and basically broke. It wasn't just about losing a watch. It was about losing something precious and something that connected him to his father. And that really was part of what drove this innovation.
Yeah, it was very personal for him. I think Casio gave the green light for eBay to pursue this Unbreakable watch project. But instead of assigning it to here's another product in our product line that we need to develop, they took a different approach this time.
Yeah, they did something different. They created a small team. They called it Team Tough. And it was just 3 engineers, including eBay, working in relative isolation from the main R&D department.
Yeah, and I do think that goes against the kind of convention in some ways in product making, especially in large Japanese corporations where you kind of have team assigned to work on parts of a product, more of a systematic approach. That they did take awareness that, hey, Team Tough, let's take a smaller team that can move faster, take bigger risk, and create a new product.
100%. And they started with what seemed like an impossible goal, the 1010 concept.
What is that? Can you break it down?
It's pretty simple. It's pretty
not like
simple.
the Triple Lindy, right?
No, and not like the 777, which is a different product. But the watch had to survive a 10-meter drop, have 10-bar water resistance, and have a 10-year battery life. And each of these was really pushing the boundaries of what was possible at the time.
Wow, I can't imagine any products today with a 10-year battery life.
Yeah, I don't think that violates all business models, probably.
Yeah. So
you'd have to have a battery as a service or something.
Well, these requirements, I feel like they might not seem extreme, but in 1981, again, this durability is probably something a lot of watches weren't even, or actually a lot of products didn't consider.
Yeah, I think they were essentially asking for science fiction. Most watches really could not survive a drop from a table height, let alone 10 meters, which is about 33 feet. So think about 3 stories up.
Yeah. Well, how often do you drop things from 3-story up, right?
Yeah, exactly.
Today, if you drop your phone from your desk, you're kind of like, oh my God.
Yeah.
But let's dive deeper into how Team Tough actually developed a G-Shock. From what I understand, Thamer, they took a very different approach.
Yeah, they did. What's fascinating is how they drew inspiration from immediate surroundings. eBay would watch road construction workers right in front of Casio's R&D center.
And they were using jackhammers in front of them?
Yes. Some of us call them pneumatic drills, but sure, if you want to call them jackhammers, fine.
Well, in my line of work, we call it jackhammers.
Okay, fine. Canadian imperialism happening right now in front of everybody's ears. So none of these construction workers wore watches because the vibration would destroy them. And eBay saw that these workers were his ideal users or his muse, people who needed a watch but couldn't wear one due to their environment.
Yeah, that's such a powerful part of the design process. Sometimes that gets overlooked. It's actually just the power of observation, just taking the time to see real people using products. And it's so easy to kind of get stuck behind the screen and assume things or look at the world through digital lens versus just spending time with users. Well, with that approach, their first attempt was what we might be calling interesting.
Yeah, to put it mildly, their initial prototype, or several prototypes, basically looked like a watch encased in a rubber ball wrapped in duct tape.
Yeah, it feels like one of those like engineering school project. Like, oh, how do you drop an egg from 3 stories? And
Totally. That's the flashback because I had to do that course.
right,
And their first attempt was really, let's completely encase the watch in rubber. And they just realized that every time they drop tested it, something would break. So they added more rubber to the outside. Eventually, it didn't work until they reached the size of a softball.
that's a good engineering mantra. Yeah, engineering mantra. More rubber.
Yes, more rubber. And they stopped when it reached the size of a softball, which they kind of recognized nobody's going to wear this. And it proved that fundamental approach was wrong. That line of design,
Actually, that might come back now, I guess.
maybe. But it led to how they were rethinking the approach to protecting the watch.
But even that didn't work, right?
No, yeah, I mean, no amount of external cushioning could prevent internal damage.
So you really have to take it a whole different direction,
Yeah.
right? You can't just encase it with more stuff.
Yeah, and this is what they were doing, right? Every time they had one of these rubber ball prototype things with the duct tape, they would go to there was a bathroom on the 3rd floor of Casio headquarters. They would drop the watch prototype from the bathroom window. It's a 10-meter drop, 33 feet. And they would basically go and do a systematic analysis of failures. Which components failed? Why?
Yeah, it's just this iterative loop, right? They're just iterating, like, and this it's a vicious cycle, right? It's you start getting to the kind of that zero sum. Like the more you try, the less return in your design.
100%. And so they went with an approach of strengthening each component individually, right? And so they call this the 5-layer protection system. And they made a lot of good progress with that as well. However, they would always have one component fail in these, again, 33 feet drop tests from the bathroom window on the 3rd floor. And eBay described it as spinning on a treadmill with no way off.
And then comes the Sunday in the park.
The Sunday in the park. Let me take a step back before I set this up. eBay, being on this endless treadmill of failure or failed prototypes, basically set for himself an ultimatum. He said the following. He said, we've been at this for a while.
Yeah, it's almost a year into development, right?
Yeah, they're over a year into development.
Right. I'm sure there's getting a lot of pressure from management. It's like, hey, what's up, eBay?
Yeah, pressure from management. Also, I think self-inflicted pressure, because he decided that this was going to be the last week. And if he didn't solve it in this last week, he would resign. And so we go through the days of the week and we get to Sunday. He goes into his office and starts cleaning after some of the experiments, goes out to his lunch break, sits on a park bench and sees some kids playing with a rubber ball. And then the eureka moment hits. What if I encase the actual watch module, the engine of the watch, inside the equivalent of a rubber ball?
Oh, so it's not the outside that...
Yeah, so you almost want to create some hollowness in the case to have what's called the floating module. And the floating module is literally floating encased in rubber.
Inside the case.
Inside the case, yep. Oh. In addition to all the other rubber gaskets and bumpers on this, they have this floating module inside the hollow structure.
That's fascinating. It really didn't come from an engineering textbook. It came from watching kids play outside.
Yeah, and there's some prototypes where they actually had a rubber ball and they had a module inside of the rubber ball, and that they just wanted to test the concept. And they're able to figure out how to get that to be something that could work inside of a hollow case of a watch. And this was the missing link, right? It was the multi-layer protection system, but the missing link was this floating module design.
Right, this isolating the module from within the case.
Yeah, and so that was the breakthrough, and that was what that allowed them to go to market. There's just a lot of technical achievements behind this watch. But before we get into the technical achievements, I want to help our listeners really see what makes this watch so special. Could you describe the original DW5000C, the first G-Shock, to someone who's never seen one, Albert?
Yeah, I'll give it a try. It's such an iconic design. It doesn't look like any other watch out there during that time. And picture a watch that looks like it was designed for a future that never happened. It's very distinct 1980s design cues. It's perfectly square. It's about 45. Well, it's exactly 45.4 millimeters across, and it breaks every conventional watch design rules. It really established, I would say, this design language of durability. And again, like back then, especially in the 80s, durability wasn't a key theme. And G-Shock established what I would say this new visual metaphor to toughness with its bumper. If you look at the casing, it has this strong, almost brutalistic exposed frame. It shows its constructions with where the screw are or rivets, and it has these shock ribbings and really tough PU elements. So the square case had bevel corners. It had a deep set digital display, recessed, 4 very prominent corner bumpers, and this very aggressive geometric bezel. And you almost picture this frame within a frame. And actually, that really speaks to its construction, but also back to this idea of isolation and shock absorption. I think the outside actually signaled what was going on inside too. And had very bold graphics. It literally says protection.
Giant type.
Giant. Yeah, so it's protection and G-Shock in bold letters on the face of the watch, on the bezel. The buttons themselves were recessed with these sculptural cards so that it wouldn't hang on anything, and had really strong buttons, but also a back case that was very durable with 4 bowl screws that held it together. Has a technical looking visible screws that were also functional. This design language of durability was in some ways unprecedented and really set a theme for many other products.
And there was also this little hinting at how tough it was with the little brick wall, kind of that brick wall border.
Yeah, on the
literally
face.
A brick wall drawn on the border of this watch.
That toughness was embedded into every detail.
The proportions are really interesting too. It's deliberately oversized compared to watches of the era. Maybe, Albert, we can talk a little bit more about the proportions because they're really quite sophisticated.
Yeah, and then actually back to like that era, like a lot of special mechanical, even digital watches were going for thinness and sleekness, like especially like for like, hey, if you're an executive, you're wearing a suit, like, oh, look how small my watch is and how thin it is, right? The thinner, the better. And that was kind of this aesthetic of sleek, modern design versus this oversized, bold design that stood out. And the proportion itself, again, maybe it ties into almost like this Transformer-esque. It's a deliberately oversized compared to other watches that era. So I think there's a mathematical precision to it. And if you look at the ratios, there's a perfect square format of the display. It was 45.4 millimeters by 45.4 millimeters. That was the size of the casing, and has the golden ratio elements. And sometimes we forget, like especially in digital watches, that display it's so small relative to the rest, because back then LCDs were expensive, and I think they invested a lot in terms of maximizing what you can get on that display. And that high contrast LCD display with its strategically placed controls and its protective elements really came all together to create this iconic design.
Yeah, Albert, and I think really what you see with this initial G-Shock is a design language of durability, right?
Yeah, and to unpack that a bit more, like it tied into this era of extreme sports where a lot of emerging sports like skateboarding, surfing, BMX in that 80s era, right? That was the explosion of the X Games.
Extreme mountain biking, 45 miles an hour.
Did it.
65 miles an hour.
Done it.
Blindfolded.
The timing of the design language really kind of hooked into also the timing of this kind of cultural phenomenon of extreme toughness, and which you still see that design language of durability as a performance cue. A lot of fashion brands like North Face to Canada Goose to Montclair still have this kind of extreme oversized proportions that even a lot of streetwear today. I could go on and on about why is Solomon hiking boots considered streetwear today? But I do think Casio was really at the forefront of that and established this design language of durability. But how was it received at that time, Thamer?
I think that's where the story takes an interesting turn, because in Japan, it was initially seen as way too unconventional.
Like it literally broke the mold.
Yeah, it was a resistance to the chunky aesthetic. There were price point concerns, limited understanding of the value prop, and they nearly canceled the product line.
Well, until the hockey puck commercial, right? And as an ex-professional hockey player,
my understanding is that you were actually on the cusp of ex-semi-pro, not ex-pro.
Well, I kind of had the same hockey career as Keanu Reeves.
Fine.
But this hockey puck commercial was really the key to kind of, I would say, tapping into the cultural zeitgeist.
Yeah, this is one of the most important moments in G-Shock's history. Casio's American division did this commercial showing the G-Shock being used as a hockey puck.
Presenting the G-Shock watch from Casio. The water-resistant sports watch that's ready for action.
It literally starts with a referee dropping this object, which you don't necessarily see because of how the shot is done. And then you see a bunch of hockey players hitting can't really use bad words, hitting the life out of this object.
This G-Shock can take a slap in the face and not even flinch.
It zooms in, and it's actually, the whole time they've been playing with this G-Shock.
Was it real or was it fake? Did they actually do it?
Well, that was the big question. There was a giant controversy. They were challenged on whether it was fake. And so Casio had a masterful PR response to this. They proved it live on TV, and this controversy became the perfect marketing moment.
I would say probably today's term, we went viral, I guess. Like it created a moment.
Yeah, and what's fascinating about is how G-Shock found its audience, or really audiences, Albert. You want to kind of shed a little bit of light on that?
Yeah, and again, there's the way eBay and Team Tough designed the product. It's through power observation. And back to that jackhammer and construction workers, professionals adopted it. It fulfilled their needs. Military personnel, first responders, construction workers, like I mentioned, but also getting the NASA certification that it's NASA flight ready, to sports professional, back to X Games, extreme sports. It really hit a spark for professionals to adopt it.
But then something unexpected happened. It became a cultural icon. It was adopted by the hip-hop community. Wu-Tang Clan was wearing these watches, part of skateboarding culture, surfing culture. It became an urban fashion statement. It was affordable luxury positioning, and it was really authentic as an object in youth culture.
Yeah, there's this whole theme and with Casio G-Shock but many other consumer products where performance for one segment of customer and users leads to cultural adoption by a whole different group. And sometimes you can't predict it and you can't design for it. I really find that really fascinating, especially in the culture of design, fashion, and streetwear.
100%. And what you see when you study how Casio managed the line is they started adapting to this response.
They start leaning into it, I guess.
Yes, they
right?
started leaning into it, and you start to see these bright white, bright yellow. There's some watches that are just, if you look at the G-Shock range, that make this initial one look very mild-mannered. And so it's a really interesting interplay between initial intent and then the response that came later and how they leaned into that response. But I want to pivot and talk a little bit about what's interesting from a business standpoint here, which is Casio did something improbable. It took a saturated market, which is watches, especially digital watches at the time in the 80s, and quartz watches, and they created a whole new category and a brand extension, all very successfully.
Yeah, definitely. And I think that broader impact, especially in industrial design and product design, I think G-Shock not only influenced watch design, but I think it went right beyond. And if you think about this design language of durability, if you look at smartphones and protective cases and to rugged laptops and tablets like the Toughbook, like from Panasonic, to how outdoor equipment is kind of like, I always look at these big giant thermos of water bottles people carry.
Do you really need it? Yeah.
Yeah. To professional gear aesthetics like that. The DeWalt Tough durable, like it's professional grade
Yeah.
consumer electronic. I think it created, again, this whole language that wasn't there before and caught on culturally.
Yeah, and it wasn't just about protection. It was really something that they proved about design.
Durability can be a primary design feature and not just an afterthought. And I like sometimes like we try to design everything and make everything like, back to like I love that the 1010, just focus on those three things. That drives an outcome, like drives a design language, but also it drives a very clear intent in what the design stands for. I think there's this kind of almost like an honesty, right, in that expression.
Yeah.
And that's so important.
100%. And you create your own kind of beauty here. It's this integration of protection and aesthetics. It's honesty, as you say, in material expression, technical features as visual elements, durability as luxury, function driving form, all these things, right? To me, it was this moment that really set the tone for a lot of product design that came later.
And I think as we kind of wrap up our exploration of G-Shock, I keep coming back to how this was all started from a broken watch and an engineer's personal drive based on seeing his father's watch break to solving, in some ways, an impossible problem.
Yeah, it's really amazing how solving one specific problem, creating an unbreakable watch using the 1010 goals, really opened up these possibilities that nobody could have ever predicted.
Right. And what stands out for you, Thamer? What are the key lessons now for designers and innovators? We've mentioned so many things that the G-Shock kind of stood for, but also in some ways created is more than just a watch.
Yeah, I think, we've been doing this for a while and there's so many lessons, but I think that will bubble to the top. One, the power of inspiration.
Right.
Really, that moment really creates that drive and that insight.
Right. You have to, and you have to observe it. You have to, and I think sometimes we make it sound too simple. It's like, oh, eureka, I have the solution. But it's actually through observation, through seeing the world and being in the moment. I think that's where that power of inspiration comes from.
Yeah, and I think, maybe if we want to extend it to things like having the direct insight, we've had to look through lots of research reports that were just kind of data on a screen or data on a paper report. And really, there's no substitute for also observing directly or living that reality that really can add dimension, add texture to this problem.
Well, and I think that's how the humans, and again, I'm not trying to go off in this different direction, but I think that's how patterns form in our brains.
100%.
It's really through that, system 2 thinking, right? It's just something that's happening in your brain in the background, and then you see that moment of clarity.
Creativity and design, really, if you can be open to being inspired, in general, it's a posture, it's an attitude, I think you will go further in your design practice. And we now go to number 2. There's an importance of clarity and desired outcomes. This whole 1010 thing was a simple goal.
Definitely.
Which was hard, but it was expressed very simply and very clearly.
Well, it was aspirational.
It was aspirational,
right?
Yeah. But it was it's like we wanted to put somebody on the moon by a certain year. That was clear, right? This is kind of the same category of that. So that 1010, really being clear in the desired outcome of a project up front really helps.
Well, and also being, again, this is a bit controversial, being able to measure your success.
Yes.
It seems like it's controversial because sometimes metrics and data kind of drives us toward being biased towards certain outcomes. But I think in this case, it was aspirational and it created clarity for this small team and very focused, right? Very focused.
And now the third one, and I want to talk about this with you a little bit, Albert, because we have direct experience with this, both on the big side and the small side. There's this agility of small teams and value of working outside the machine. And I think in your work at Nike and Microsoft and my work at Microsoft and other places, we've done both roles of kind of we're outside of the machine and we're inside of the machine, right?
Yeah, and wow, I could go on this one. Like small doesn't mean necessarily better. I think that sometimes it's kind of quaint. It's like, oh, just have a small team and they'll just go off and do something that no big team can do. I think if you unpack it, is having focus, back to that moment of clarity, but also the ability to iterate, make decisions, and really learn. Like when you have large team changing a path, especially a design path, it's really hard.
It could be really, you get a lot of resistance.
You have to get everyone on board. Like, hey, well, actually, that didn't work. We're going to go this direction. I think that's the part often gets lost in a lot of design conversation and even design schools and corporation, is being able to kind of change direction versus being locked in to a path, and especially large teams.
100%. And I think when I study these projects, whether I'm working on them or studying case studies or whatever, there's this ability to iterate in your concept, and the ability to have less friction between iterations without losing focus is a key factor, I think.
Yeah. And then for me, there was also this idea of design for one set of audience and then adopted by another. I think it's another learning. Not to say it's easy, but there's something there.
Yeah. And what I think the lesson from there is how to lean into it, right? And how to embrace it. It can be almost like this organic pivot.
Yeah. But recognizing it, I guess maybe that's the important thing.
Yeah.
It's hard to design for it, is what I'm trying to say.
100%.
The other observation I had was this idea of failure in your home market doesn't necessarily mean the concept is not valid, especially like the initial response in Japan, at least in the Japanese market, to G-Shock was like, hey, it's kind of weird and it's a weird proportion, it's too big, or like the value, price point, like why am I paying more for this? I don't need it. And then the US marketing team realizing like, hey, there's actually a story and a positioning here. And back to that product market fit, they created a commercial that really emphasizes durability and toughness. And that's what caught on. And I think that's really important. How do you position the market, but also how you communicate your product to an audience?
Yeah.
Getting that story out was so critical.
This is really a story and a case study I could go on forever. It really has a lot of depth, a lot of lessons. I'm also a fan of the brand. I'm wearing a direct descendant of the DW5000C on my wrist today. I think we can talk for another hour, Albert. What do you think?
Well, I think we should wrap, or else we will definitely talk on for another hour.
Okay, fine. This is a wrap for today's episode. Thank you, Albert. And thank you for joining us for this episode of The Design Vault, diving deep into the story of the first G-Shock. Thank you, and until next time.
Thank you.